So in this question, we have a couple graphs, and we'll do an analysis to make sure we know what we're looking for before we even read the question. The origin is present on both graphs. Y-axis is force in newtons, both graphs. The x-axis is distance in meters for both units. So therefore, we can read any questions asking about force or position or distance or displacement would be read off the graph. The gradient is F over x, or newtons per meter, which is the same units as K, the spring constant. Now, we don't know the context of this yet, but that's what the units tell us. So if we need to know about the spring constant, that would be the gradient or the slope. The area multiplying the axes is F times x, which is the work. So any questions about work would come about by determining the area. If we look at the area of these two graphs, take first force 1, and we look at the area of the second graph, we should see that it's apparent that the area of force 2 is quite a bit larger. And we could count up the blocks, just doing the full blocks, 1, 2, 3, 4, 5, 6, 7. Whereas on this side, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and many more full blocks. So the question tells us it's two trials of an experiment. Work 1 and work 2 are the work, so we know this is an area problem. Completed by force 1 and force 2. How do the works compare? Well, what we know is work 2 is larger. So work 1 is not greater than work 2. So those two choices are out. And we know that work 1 is less than work 2. So those choices C are in there. Now, work is equal to the average force times the distance. This question is about the work, which comes about by the area. So C, work 1 is less than 2 because the average force is smaller than the average value of force 2. This is true, but it's not apparent. One could argue it. Because if work is force times distance, what you're basically doing is taking the area of a rectangle, which would be length times width. So for that to be true, then we are looking at a greater value of the force in force 2 than we would to produce the same area as force 1. But that's not very obvious. But that looks like that could be the right answer. Because at the midpoint, x equals 5, the value of force 1 is less. That has absolutely nothing to do with it. That doesn't lead us in any way toward an area. Now, my personal opinion, this is a very poorly done question. Because while it's true there's an average force, it's not readily or easily determinable. This is really simply about the area of force 2 being greater.